Hey guys, okay, so now we're gonna go ahead and start our calculations. Okay, so according to Charles' law, um, this is the equation for Charles' law. So V1, that's the volume, the initial volume divided by initial temperature is equal to the final volume divided by the final temperature. Initial, like the starting, is with a 1, and the 2 is final. It's at the end, how it's, and basically you're just looking at the behavior. Okay, so now let's go ahead and start um, making sure you write the correct numbers here. Okay, so we're going to start by reading it. A 5.2 liters sample of gas. So initially, it's 5.2 liters because they have a sample of gas of this liter, and this liters is heated, and it's saying from, that means it started at 298 all the way to 373. Okay, so right off the bat, we know that this is the initial, okay, because this is the sample, this is the beginning. They're talking about how they have this much, and so this will be your initial volume, and we know it's volume because it's liters, and it goes from, and this will be right here, this one should be temperature. That will be your initial temperature. Okay, so that will be your T1, and then finally it goes to your it goes all the way to 373. Okay, so 373 will be your final temperature, because again, this is K, that means kelvins, that means it's temperature. So that will be your T2. Okay, so what is its volume in liters at the higher temperatures if the pressure and the amount remains constant? So in here, it's asking for the, what will be the final volume of it. Okay, so we will have to find out, we're trying to find out the final volume, which is V2. Okay, so now let's go ahead and start putting these. So this one will be 5.2 liters. And the 298 Kelvin will be T1. That's the initial temperature. It started at 298, and then it finalized at 373 Kelvin. So it would be 373 Kelvin. Okay, and so we're trying to find out the final volume. Okay, now since we're trying to find out the final volume, this one, just like you saw it, we do need to cross multiply. Okay, at least for this one, we're going to go ahead and cross multiply. So you're going to just make sure you cross multiply it. And then once you cross multiply, then you could easily move it around. Okay, so it would be so if we basically it would be T1, so it would be T1 times V2, and that equals to V1 to T2 times, and I'm going to put parentheses just so I can know you're multiplying. So now once you cross multiply, you can go ahead and plug it in. So T1 would be 298 Kelvin. So T1 is 298 Kelvin. And then you multiply by volume 2. Now volume 2 doesn't have a number, so we're trying to actually find out about that one. So we're just going to keep the letter, the symbol of it. Okay, so V1 would be 5.2 liters, and T2 would be 373 Kelvin. Okay, so once you have it set up, it's really easy just to go ahead and move them around. It's going to be, and we're going to have to move that 298 Kelvin. We need to move that T1. So to find out what's your volume to. So it will be divided by 2. Why? Because this is multiplying. The opposite of multiplying is division. So it will be 298 Kelvin. Remember, this is the one we're moving. We're not moving the V2. We want to leave it alone. Okay, we want to move the 298 with the other numbers. This is the only number, so we've got to move it to the other numbers. So you do the same thing to the other side, 298 Kelvin. And then you cancel those. And if you think about it, 298 divided by 2 is just 1. Okay? Okay, so now that we're done with that, it will be V2. Okay? And then we just, you just use your calculator, the one that you have there in Schoology, which is 5.2 times 373 equals 193.96 divided by 298 kelvins. That means you should have a 6.5 liters. Okay, that should be your answer. And just make sure you have the right setup. And that's it, you guys. That is it.